I want to do a quick tutorial on Classicladder for LinuxCNC to help anybody who is interested in PLC logic programming for LinuxCNC but doesn't quite know where to begin. This is where I was a couple of days ago, so I want to help anybody who is looking to do this, because there's not really a lot of information online for Classicladder per se, but there's a lot of tutorials and basic introductions to PLC programming on YouTube. So if you do a quick search for PLC basics, you'll find a lot of tutorial videos, and you're gonna find one from a guy who's very adamant about a couple of things that I'm going to cover in this example. So what I'm going to do is I'm going to create spindle override buttons in Classicladder, and I'm going to utilize a deadman switch on my PlayStation controller to basically lock out the override increase and override decrease. That way there's a safety factor built into my PlayStation controller, so I don't just hit a button and have the spindle inadvertently increase in speed or decrease in speed. There have to be a physical deadman switch or acknowledgement switch in order to activate those two buttons, and we're going to do that with Classicladder. If you are just starting to create your configuration, you would enable Classicladder on the last page of your PNC configuration wizard to create a PlayStation controller configuration in PNC-Conf. You go to PNC-Conf, and one of the very first options on the bottom here is Show Advanced Option Pages. From there, you would create your USB input as your external control to set up your jog buttons and create your HAL UI components and whatnot. I have a tutorial on that as well. Once you create your profile for your machine, I'm using GMOCA Pi, but you can do this in Axis as well. In Axis, you just go File, Ladder Editor. In GMOCA Pi, you go to Settings, CL Ladder, and that will bring up your ladder interface. The other page that we're going to be using is our HAL Show, which is our HAL configuration menu. And the HAL configuration menu, for anybody who's not aware, is a tree view of all of our components, pins, parameters, signals, functions, and it just shows us the threads that are running, and it shows us the things that are tied to our threads. Once we run through the PNC-Conf and we get our configuration, we'll not only get a pin section for Classicladder, but we'll get a pin section for our PlayStation controller labeled input. If you didn't run through PNC-Conf and you want to add this to your current configuration, there's a couple of HAL commands that you would set up. You would do a load RT, Classicladder _RT, load USR, Classicladder, and then this ladder CLP is just a file name that is pointing to the ladder.clp file that I have here. You could basically just create ladder.clp in Mousepad and plop it into your configuration file for your machine. And when you create your Classicladder, it would pop up, and then you would just do a new, and it would create a new ladder program for you in your sections manager here. So the first thing we want to do in this scenario is go to our watch list, go to our input list, select our input 0. Now these are all the available buttons on my PlayStation controller. The first section is the directional hats and my analog sticks. The BTN section is all of my buttons. Let me erase that. So if I go to button A, button B, button C, select, start, TL, TL2, TR, TR2, R2D2, button X, button Y, button Z. Don't sue me, George Lucas. Looking at our HAL configuration, if I press any button on my PlayStation controller, we will see which button becomes active in our watch list. If we go to the Show section and I select the button A source here, it shows me the HAL pins that I can link to in my HAL file. And I would use this to create a net command, net something, input.0 dot btn-a, and in this case not. And I could say that when this button is not being pressed, link it to something within my LinuxCNC configuration. I'm not going to do that, but just to show you, in case you've never used HAL configuration before, you can use it to test out net commands. You can use it to do set parameter commands with set P. You can set signals with set S. If you have a command already netted from LinuxCNC to a command, so if I in this case I'll say net input dot 0 dot button dash a dash not. It's going to yell at me because I didn't give it a name, so I'm just going to say net something to input dot 0 dot button dash a dash not. It's now linked. So if this were a pin that I could use set P to set a parameter on, once it's linked with a net, I would have to use set S and change it with the word something instead of set P input.0.button dash a dash not. I would say set S something. So I hope that clears that up a little bit. I figured that out the other day, and I was like, ooh, this is cool. So anyway, going back to my watch list, I've got my input buttons. I'm going to scroll up to my Classicladder section. I'm going to go to my input 1, or input 0, sorry, input 1, input 2, and make those available on my watch list. I'm going to go to output 0 and output 1 on my watch list. Now, just knowing what I'm going to be building, I know I'm going to have to use 3 inputs, one for my select button, which is button TL2, my spindle increase button, which is going to be button B, and my spindle decrease button, which is going to be button C. Once those are established on my HAL watch list, I can then go to Classicladder. I have a blank canvas that I'm going to be using. I'm going to go to Editor to display the Edit interface, or the Edit menu. If I were to use Add, it would add a new section of ladder underneath the current section. Insert will insert a section above the current section, and Delete will delete any selected sections. And you know that a section of ladder is selected by the little red lines left and right. In this case, I'm going to go to Modify. From there, I get my Modify menu. At the top, I've got my selector and my eraser, so I can select an object or I can erase an object. Below that I have my input section. So I've got normal open input, normal closed input, rising edge input, falling edge input. Below that I have my connection section, which is like a conjunction junction, I guess. What these do is these lines will connect input signals to output signals. Looking at PLC, PLC is read from top to bottom, left to right. So from left to right, I have inputs, I have processing that goes on within the PLC, and then I have outputs. So think about lube pumps, coolant pumps, door interlocks, things like that. Again, if you have a lube pump that is on a timer for 10 seconds and then shuts off for 10 minutes, you would build that in PLC logic instead of having to order timers, relays, things like that off of Amazon or the usual suspects and physically mount them into an electrical cabinet. This circumvents some of your physical hardware in exchange for virtual hardware. You create virtual input signals, virtual relay signals, and virtual outputs, and have timers and counters in between to perform various tasks. It's not going to eliminate contactors, large high voltage relays. It's not going to, just because you create a circuit that's called lube pump doesn't mean that the PLC is going to physically lubricate your machine. You have to buy the lube pump, but then you can create the timer logic within PLC to control the lube pump via your breakout board output going to a physical relay that would trigger the pump to go on and off. In the case of one of my machines, I was using a physical relay to switch between my tool setter and my spindle setter, where now I can use ladder logic to switch between two inputs on my G540, or in the case of my new machine, my Mesa card, I will use two inputs and toggle between the two of them with Classicladder to monitor which probe is being used at any given time. And I would still use M64, M65 outputs to select between the two circuits, but I can also build into my spindle probe circuit a spindle interlock so that when the probe is in the spindle, plugged in and active, the spindle will not turn on. So there's things like that you can build with PLC logic as well. So getting back to this, we've got our input section, we've got our connection section, what's your function? Down at the bottom we have our outputs. The ones we're going to be working with tonight are the normal open input, normal closed input, and normal open output. If you watch the tutorials on YouTube, there is a guy that is adamant that there is a huge difference between normal open input, normal closed input, and normal open switches and normal closed switches. In PLC logic, they're not actually called normal open and normal closed. They're called make coils and break coils. And when you watch the instructional videos, you will soon see that a make coil and a break coil do not care if you're using a normally opened switch or normally closed switch. All it cares about is digital input 0 and 1. So keep that in mind when you're writing your ladder circuits. Classicladder doesn't care if your push button or your switch is normal open, normal closed. It just wants to know, are you making a signal? Are you breaking a signal? That's it. So to get further into this, if I go to the var section in Classicladder, var shows me my B's, I's, and Q's. What are B, I, and Q? B's are internal relays within Classicladder that you would write logic to toggle on and off. The I section are all of your inputs. An I is user assignable through HAL. A B input or B relay is not. The Q section is our output section, and this will show us all of our available outputs. If I know on here, if I click on Q0 and Q1, I will see my Classicladder out 0 and my Classicladder out 1 become active on my watch list. All of our I/O will utilize these labels: I0, Q0, I1, Q1, and I2. There is a way that you can name all of your inputs and outputs, and then you have the display symbols toggle, which will switch between the name and the symbol displays. The symbols being I/O and QO. So getting into here, the first thing I want to show you is if I just assign an output with a straight line from the input side connecting to the output section, and I hit OK, you see that the circuit is being made with the pink line and that the output is being triggered within the watch list. I'll do that again underneath, connect it with a line, use the object selector to select the output and give it the name of Q1. When I hit OK, both of the outputs turn on, both of the signals connect. If I go to Modify and create a normal open input, on rung number 1, hit OK, you'll see that this input is waiting for a make signal. It's waiting to be connected. Therefore, Classicladder out 0 is off, where Classicladder output 1 is still turned on. If I click on any of the I/O in Classicladder, it'll show me the variable name and it'll show me the HAL signal that the input is connected to. Right now, input 0 has no HAL signal connected to it. But I know that I want to connect input 0 to my input button TL2. Input 0 is going to be my deadman switch. If I go to show and I do a net command, net deadman, I will say input.0.button-TL2, and I'm going to net that to Classicladder.0.in-00. Once I have that signal netted between Classicladder input 00 and button TL2, if I go to my watch list and I look at my ladder, when I press the select key on my PlayStation controller, you'll see that a couple things happen. You'll see that input button TL2 lights up just like it did before, but now Classicladder.0.in-00 also lights up because it is now tied to this HAL input signal called deadman. And it also triggers the output to become active. So that's the first step in our ladder creation. We want to use the same deadman switch on both circuits. So what I'm going to do is I'm just going to create another make coil with the same exact name as the one above it. So now when I go to OK and I press the select key, it now makes both output signals. Now I want to assign button B to a speed increase, button C to a speed decrease. Knowing that my net command for input 00 worked properly, I can select it, use Control C to copy it, open up my PostGUI HAL file, and I can paste it into my HAL file. I have a couple at the bottom here just to show. You paste them in, whatever you want to call it. I called it spindle release before, but now I'm calling it Deadman. If I wanted to use the same nomenclature, I would just change that to Deadman. I have these commented out anyway, so it doesn't really make a difference. So now I have my Deadman switch enabled and working. The next thing I want to do is I want to assign the button B and button C. Button B will go to the first rung, button C will go to the second rung. So from here, I want to net spindle dash increase to input dot 0 dot button dash B to classic ladder dot 0 dot in dash 01. It gives me confirmation that those signals have been linked together. I haven't assigned them here yet, but I would just go back to ladder, go to my edit menu, modify, select my input coil, and just click here, change this variable to input 1, hit apply, hit OK. Now when I hold the select key, the bottom output signal is still triggering, the top one is still not triggering. If I press button B, you'll see that the coil lights up and the input lights up in my watch list. Only by holding in the select key and pressing button B will the circuit become complete and send the output to LinuxCNC. The outputs can be used internally within LinuxCNC, or they can be used externally, again, to trigger relays and other things within your electrical cabinet. So we have our top rung working the way we want. Now in PLC logic, this is called an AND statement. It means that the output will not trigger until condition 1 and condition 2 are met. If I modify this real quick, I just put a break line here. I take out this coil, select the one underneath it, and make that input 1. Connect the 2 with the vertical line. This is what's called an OR statement. So the OR statement means that the select key will fire the output, or button B will also fire the output. You can see that there. Both of the buttons can be hit together, which can create some issues in certain cases with PLC. In that case, you would use an exclusive OR or an XOR statement, which would just include shutoffs for each section of the ladder. I'll show you. I'll see if I can do this on the fly. I'm going to call this input 0. Call this input 1. So right now, if I hit the select key, the select key passes through to the output because input 1's not being triggered. If I press the B button, it passes because input 0 is not being triggered. But if I press either or if I press them both at the same time, sorry, not either or. If I press either or, they work fine. But if I press both of them at the same time, the output does not trigger and the coils just die right at the I1 and I0 break coils because those input signals are preventing both buttons from being used at the same time. So that is an exclusive OR statement in PLC. So what I want to do is not quite exclusive OR. I want to go back to what I had. So I'm just going to erase. Actually, I could just insert lines, delete the vertical connection. I'll select this input, rename it back to input 0, apply that, create input coil 1 here, and we're back to where we were. You can see how quick and easy it is to modify PLC logic in Classicladder. You're not writing HAL components to do and or an exclusive OR. You can just build it all graphically within the ladder environment. So now the next thing we want to do, we want to create another input down here, and we want to call that input number 2. We want to tie input number 2 to button C. So we'll go back to our HAL configuration. We'll do net, spindle, decrease, input .0 button C, classic ladder .0 in -02. If I go back to my ladder section and I forgot I was still in edit. Go back to my ladder, hit OK. If I click on each of these coils, it'll show me spindle increase, spindle decrease, dead man, and right now our outputs don't have any HAL signals connected. But internally, I've got my dead man switch working with the select key. I've got input 1 firing and input 2 firing, which toggles output 1, output 2 really, but they're output 0 and output 1 because computer terminology. So now we know that our dead man switch is working, our circuits are connecting. Now we want to tie these into our configuration for LinuxCNC. Because I'm using gmocha-pi, I can go into gmocha-pi, SPC spindle, and I've got 2 components that I can tie to, increase and decrease. I can also use the HAL UI component if I'm not using gmocha-pi. I can use the HAL component, spindle, 0, override, increase and decrease. But I'm using gmocha-pi, so I'm just going to stick with those. So I go to gmocha-pi, SPC spindle. I'm going to go to show because I need to know what the increase and decrease pins are. So our increase is going to be gmocha-pi.spc_spindle.increase. So what I'm going to do is I'm going to tie that into a net. I'll call that spindle. I should be able to do spindle increase. I should still have the functionality to do it, but let's see if it alarms out. Spindle increase, gmocapi dot spc underscore spindle dot increase classic ladder. Now we're going to use the output component .0 .out -0 0, and I'm going to get an alarm because it's already tied to something. So it's telling me that it's already been assigned to button B. So all we have to do in this case is just change the name of the net component. So we'll just say net instead of spindle increase. I didn't think it was going to give me or let me do it, so we'll just say spindle up. And that works. It gives me confirmation that spindle up has been assigned to the output, and you'll see right here spindle up is assigned. We'll call this component spindle down, and we will say spindle dot decrease classic ladder .0 .out 0 1. So now looking at classic ladder, we don't see much of a difference. But if I go into gmocapi, go to my main page, home everybody out to make sure that she's happy. It's hard to see here because my screen resolution is so small that my LinuxCNC gets cut off. But okay, so here, dead man switch on, spindle increase, spindle decrease, and you see that the percentage is moving when I press the buttons. If I don't press the dead man switch and I activate input 1 and input 2, nothing happens. So in order to trigger those outputs, because of classic ladder, I use the dead man switch and everything works as planned. So I hope this helps everybody looking to create basic circuitry in classic ladder and tying it to HAL components. This has been something that has eluded me for a long time. I work in the machine tool industry, and I've been begging, I mean literally just asking at least a couple times a year for the last 16 years with my company if I can go take ladder PLC classes, but they always tell me, well, PLC is more of a service thing, and your applications, you're more on the front, and PLC is what happens in the back. But being that I've started building my own machines, I now have a reason and an excuse and physical hardware that I can mess with to create PLC logic, test PLC logic, and learn PLC logic. And again, there's a bunch of information on the internet, but if you're not doing it, it doesn't make sense. So I hope that this is helpful to anyone and everyone interested in linking HAL components to classic ladder logic. And if you have any questions, I may or may not be able to help you. I'm just scratching the surface with this, but I may be able to help you. Just leave a comment in the section below, and if I can help you, I will help you to the best of my knowledge. So thanks for watching. Please be sure to like and subscribe, and I will see you soon.